This is another problem from right triangle trigonometry. Find the height of a chimney when it's found that on walking towards it 100 feet in a horizontal line through its base, the angular elevation of its top changes from pi over 6 to pi over 4. We need to find the height of the chimney. It's very important that you have a clear, proper diagram before start working on these kinds of problems. When something is a straight line, you have to draw it as a straight line. Don't draw curves for straight lines. So let me first go ahead and draw a proper figure explaining this problem. It all happens on a horizontal plane. Let's assume this is our horizontal plane. And we have a chimney. It's going to be a vertical chimney. Let's assume that this is our chimney. Somebody is looking at that chimney from a point on this horizontal plane, let's say somewhere here. The initial angle of elevation of its top is pi over 6. That means if I connect this starting position with the top of the chimney, that angle is going to be pi over 6. Let me label the angle as pi over 6. Then what he does is he walks 100 feet towards the chimney. So let's assume that his new position is somewhere here. From that new position, the angle of elevation is pi over 4. That means if I connect that new position with the top of the chimney, it's going to be 45 degrees. This is only a sketch, therefore it's not going to be perfect in terms of dimensions, but you can see that the straight lines are drawn as straight lines, not as curves. The angle right here is equal to pi over 4. The distance between these two positions is 100 feet. So let me show that as well. We need to find the height of the chimney. Let me show the height of the chimney also. Let me label the height of the chimney as h. Now, what can you say about the distance between the second position of the person and the base of the chimney? That should also be equal to h. Why? Because we know that this angle right here is 90 degrees. The angle right here is given as pi over 4. Then what should be this angle? That angle should also be equal to pi over 4, which means this triangle right here is an isosceles triangle. Isosceles right triangle. For an isosceles right triangle, we know that this side should be equal to this side. If you don't like to write it that way, that's completely fine. You can write down an equation for tangent pi over 4. Tangent pi over 4 is the opposite side divided by the length of this side. You can label that length maybe as x. So tangent pi over 4 will be equal to h over x. But you know that tangent pi over 4 is equal to 1. Therefore, x should be equal to h. Alright, now I need to find h. In order to find h, I will look at this larger right triangle. When I look at that larger right triangle, with respect to the angle right here, angle pi over 6, h is the opposite and all of this distance is the adjacent. Using those two lengths, I can write down an equation for tangent pi over 6. And we already know the value of tangent pi over 6. Therefore, we can quite easily solve that equation and find h. So let's go ahead and do that. Tangent pi over 6 should be equal to h, which is the opposite, over adjacent 100 plus h. We know that tangent pi over 6 is equal to 1 over square root 3. That should be equal to h over 100 plus h. We can multiply all of this denominator with the 1 on top on the left hand side, and we can multiply this denominator square root 3 with the h on the other side. Then we get 100 plus h. In fact, 1 times 100 plus h is equal to square root 3 times h. I need to subtract h from both sides. so that h can be isolated on the right hand side. That way I will only have a 100 on the left hand side. On the right hand side I will have square root 3h minus h. Now what? I can factor out h from right hand side. Then I have 100 on the left hand side, and on the right hand side, once h is factored out, the first term is square root 3, that minus 1. Now, in order to isolate h, I need to divide both sides by square root 3 minus 1. Then I get h to be equal to 100 divided by square root 3 minus 1. What are the units of this? Remember, the given distance in this problem was given in feet. Therefore, h should also be given in feet. Now, this is a final answer for my class. However, some instructors do not like to have irrational denominators like this. For them, you need to rationalize the denominator. If you need to rationalize the denominator, you have to multiply both top and bottom by square root 3 plus 1, which is the conjugate of square root 3 minus 1. Then you can simplify that using the relationship a minus b times a plus b. A minus b times a plus b is simplified to become a squared minus b squared. Once you multiply both top and bottom of this answer by the conjugate of square root 3 minus 1, your answer should be equal to h equals 100 times square root 3 plus 1 divided by square root 3 squared, which is 3, minus 1 squared, which simplifies to become 2. So there will be a 2 in the denominator. We can quite easily simplify the 100 from the numerator and the 2 in the denominator and write down the next rationalized final answer as h equals 50 times square root 3 plus 1 feet. This simplification is not a required simplification for my class. However, if any student wants to do that simplification, I'm completely fine with that as well. Some other instructors may also need you to do some more. For them, even this term may not be making much sense. In such cases, you will have to use your calculator and multiply 50 with square root 3 plus 1. Alright, that's it about this problem. Thank you so much.